talking to you. This is Goddess of Science Physics, and I'm Mrs. Bolvin. And today we're going to talk about power, which is part 2 of my energy series. So, usually when we talk about power, it's like, oh, we lost power because of the storm. That's power, but it's a little bit different than what we're talking about when we talk about power in physics class. Power equals the amount of work done divided by the time interval during which the work is done. So it's the rate that work is done. Okay, so when you're carrying a load up some stairs, it doesn't matter if you walk or you run, the amount of work that's going to be done is exactly the same. So power is the rate at which work is done. Now, if you run up the stairs, you're going to you're going to have more power than if you walk up the stairs, because if you run, you're doing the work in less time than if you walk. So the formula for power is power equals work done divided by the time interval. And because we've already used P for pressure, we're going to use POW, which is a little bit weird, for power, and that equals work, capital W, and remember, capital W is not weight, it's work divided by the time. So, oh my gosh, all of it came in at once. I'm sorry about that. A high-powered machine does work rapidly. If it has 2 times the power, the engine can do 2 times the work in the same amount of time. Okay, that makes sense. Or the same amount of work in half the time because it's working twice as fast. So the unit of power is something called a joule per second, because work is measured in joules and time is measured in seconds, so joules per second. Because that's a little bulky and we're not in the chapter of awkward units, they've actually given it a name. It's called a watt, and you've probably have heard about this before, like if you get a 45-watt light bulb for your lamp, that's a unit of power. So 1 watt, and notice is a capital W, of power is used when 1 joule of work is done in 1 second. So when your parents get their electric bill, the energy consumption is measured in kilowatt hours, and a kilowatt is 1,000 watts. When you're talking about like hydroelectric dams putting out a certain amount of energy or electricity, it's megawatts, it's 1,000,000 watts. 3 main engines of the space shuttle can develop 33,000 megawatts of fuel when the fuel is burned at an enormous rate of 3,400 kilograms per second, that is. So lots and lots of megawatts there. In the US, we use horsepower to rate engines and kilowatts for electricity. In the metric system, automobiles are rated in kilowatts. And if you were wondering what a horsepower is, it equals 0.75 kilowatts. And that's it for this time. Thanks for joining me. Have a great day.